Synergy 2025. At SAE India, we had identified the gap between the engineers, skill levels of the engineers coming out of the colleges and industry expectations as a focus area for improvement. Many of the engineering colleges, the curriculum is not in line with what's happening in the industry. As a result, the engineers joining various organizations have to be trained for a long time to make them useful in terms of contributing to what the organization does. So SAE India has an engineering education board which organizes various events for students like competition like Baha, Supra, FE Cycle, etc., where the team of students from different colleges conceive, design and also make the prototype which would be checked, and then the vehicle would be run on a test track to check its durability, based on which the winners are declared. The basic intention is that students should go through the whole process of how things are planned and executed. This also helps the students in working as a team. Also, we organize various technical sessions, etc., to expose students and also the professionals in the industry to latest technologies, change in technologies happening in the industry, etc. Right now, auto industry is at a crossroads and there are a lot of technological changes happening in the industry because of the change in the source of energy for the automobiles. I will come to the details later. So this is a good opportune time for all the professionals and engineers, students to cash on these opportunities to play a critical role in doing things which are required to meet this transition. I would briefly talk about Indian auto industry, how it evolved over years, very briefly, and then talk mainly about the energy transition happening in India. So, it's very difficult to talk about evolution of Indian auto industry without talking about Maruti. Before Maruti came into existence, there were hardly 2-3 manufacturers who were making passenger cars and 2 manufacturers making two-wheelers. And everything was controlled by government, including the number of vehicles what can be made. And there used to be long waiting for even a two-wheeler, especially Bajaj Auto. And people used to say that if you book today, your grandson will get the delivery of the vehicle. It was that long a waiting. And Maruti Udyog Limited, which originally was Maruti Limited, which was started by Mr. Sanjay Gandhi, who was second son of our Prime Minister, late Prime Minister Indira Gandhi. He had a dream to make a passenger car, people's car, for 10,000 rupees. So he prepared some prototypes and set up the plant what is there in Gurgaon now, where Maruti Udyog Limited started its operations. Unfortunately, he died in an air crash in 1980, and subsequently the Maruti Limited was nationalized by the government and Maruti Udyog Limited was formed. Then there was a search for technology provider. After considering various automobile manufacturers, Europe and Japan, Suzuki Motor Corporation was shortlisted to be the joint venture partner, and joint venture was formed on 2nd October 1982. And in 14th December 1983, the first car was released. This is Srimati Indira Gandhi giving away the keys of the first car to Mr. Harpal Singh from Delhi. This was a big transformative change what happened in Indian auto industry, which totally revolutionized not only automobiles but also the component manufacturing, and the present state of auto industry is mainly because of what happened with startup Maruti Udyog Limited in collaboration with Suzuki Motor Corporation. After launch of Maruti 800, subsequent every year different models were launched by Maruti, the van, the Gypsy, etc., and also new model of Maruti 800. This is what actually government also permitted foreign direct investment in automobile industry. As a result, most of the vehicle manufacturers from different countries have set up their facilities in India to make their models in India for Indian customers. With the entry of every new manufacturer in India, the choice for the customers has increased, and also the basic awareness of Indian customers and expectations also changed drastically with years. When Maruti started, we were wanting to buy the components from that time component manufacturers who were supplying to Hindustan Motors and Premier Automobiles. Unfortunately, the components made by Indian vendors that time, in most cases, were not able to meet the quality standards as per Suzuki requirements, which Maruti adopted. So we had to work with the component manufacturers to upgrade the basic design of the parts and also the quality of these parts and meet the volume requirements required. This is one of the major changes which happened in the auto industry in the component sector. If you compare Maruti Udyog Limited, which was formed as a joint venture with technology transfer from a Japanese company, and the way it succeeded in Indian industry, you compare with what happened with many other government public sector companies which were getting technology from outside for their projects. What made the difference in Maruti was when joint venture was formed, it was decided that in addition to the technical details and know-how, we'll also get all the systems and procedures what are followed in Japan, and also daily working systems made all the difference to Maruti. Like Maruti was the first to introduce the common uniform for all levels of employees, common canteen where same food is eaten by all members starting from MD downwards, and open seating where there are no cabins, and irrespective of the designation, everybody sits in open along with his colleagues who are working with him. So these, though they look very simple now, these initiatives made all the difference to the way Maruti evolved. And in my 36 years of stay in Maruti, I had seen auto industry, especially passenger car industry, grow from less than 1 lakh in 80s to almost 4 million passenger cars last year. And the variety of models which are available for customer to choose from is more than 190 models. And with reference to the regulatory things, India is at par with most developed countries like Europe. Initially, a vehicle was supposed to be a mode of travel from one place to other. And customers used to look for value for money, and of course quality and reliability. From that, it changed to how the design is, whether it's aggressive or conventional, etc., and what technology is being deployed in the vehicles, and also how exciting is the drive. So the basic expectations of the customers continuously change over years. This is just to give you an idea. In a automobile, most of the parts are regulated in terms of there is a corresponding standard which has to be met by these parts, and there is a certification of the vehicle by test agencies like ARI or ICAT. And unless the vehicles comply with all these requirements, you cannot sell the vehicle in the market. So there are a lot of controls the way the vehicle can be designed and configured. These standards basically cover not only the functional requirements but also safety, environmental, etc. In the transportation, we have what is called personalized transport or public transport. And over the years, there's not much change what has happened in the way we are commuting from place to place. And unfortunately, in India, public transport is not up to the expectations. As a result, it is last resort as a choice because the expected comfort or convenience is not provided by the public transport what is available in now. And also, they are not able to cater for the total requirement of people who want to use public transport. As a result, there are a lot of there are too many people trying to get into a public transport vehicle. World over, auto industry is going through major disruptions. The vehicle is not only being a personalized transport, but also we are seeing more and more of shared mobility. And then there are a lot of connectivity requirements which are which are demanded by the customers. And also various organizations are working on autonomous vehicles, which would mean that the vehicle would not have any driver driving the vehicle, and once the route is set, the vehicle will go through roads to reach the destination without any problem. Unfortunately, in India, to opt for autonomous driving is very, very difficult or risky, because most of the road users, like all of us, don't follow the traffic rules, or we have any discipline. We neither have lane driving etiquette, nor we maintain the minimum distance between the vehicles, nor we stop at the signals, and everybody wants to drive the vehicle on road as he wants. As a result, if you have autonomous vehicles on road, the computer will get into do loop, and it will not know what to do, because it's so confusing situation on the road. So, as far as autonomous driving is concerned, I think India is still not ready for this, and it is in all your hands to become a disciplined driver when you start driving vehicles. And some of you must be driving already. So please follow traffic rules and stop at all signals when required. I mean, that will help a lot of things, and also avoid accidents. And also the electric mobility, which is required to reduce or contain the CO2 emissions which come out of the vehicles, because CO2 emissions will deplete the ozone layer and impact the global warming. So the whole world is working towards reducing the carbon footprint of what they are doing. It's not just limited to auto industry, but also all other manufacturing processes, etc. So every time what we are doing has a carbon footprint. If I am using my car from my home to reach here, I have generated so much of carbon dioxide, which is harmful for ozone layer. In India, based on what is happening globally, this is what is required for India: connected, shared, and electric. And also, looking at the various issues related to electric vehicles, it is felt that most of these liquid fuels and gas fuels are going to coexist with EVs for a long time, till the EVs become affordable and everybody is comfortable to use a electric vehicle. This is basically to give you an idea what goes into an electric vehicle. The total powertrain would be different, and there is no exhaust system, because it is the battery which would be powering the electric motor which would drive the vehicle, and there is no exhaust gases. So the roadside emissions from electric vehicle are not there. So that is a great contribution to improving the air quality what we are breathing, and with IC vehicles, this is the biggest concern. All forecasts have indicated that auto industry is going to grow threefold by 2030, and it's a continuous growth curve which is being predicted for auto industry. Auto industry in the world is considered as indication of the economy of the country. So if auto industry is growing, that means the economy of the country is good. However, increase in automobiles with IC powertrain has some issues. Generally, with increase in numbers, there's a lot of congestion on the road, and average speed of movement of the vehicles is very low. I mean, this we are experiencing already in Delhi and other cities. And the most important aspect is the tailpipe emissions. Tailpipe emissions coming from a IC engine has carbon monoxide, HC, NOx and particulates, which are very harmful for the health. And also, India is one of the top 15 countries where the number of accidents are very, very high. And also, is very unfortunate that we have almost 150,000 fatalities every year. 150, 150,000 fatalities would mean 500 air crashes every year, which is very, very, very high, and it's a very big concern because we are losing a lot of productive man hours, productive people in accidents. From sustainability, I'm from TERI, so TERI works on all aspects of sustainability. If I consider from sustainability point of view, what could be solution for the various issues what I just mentioned for automobiles? Avoid what is not good. So right now what we are discussing is about transportation. So we should minimize or avoid unnecessary movement of people and material. During COVID days, we were not allowed to go out, so we all thought that everything will stop, but we were able to continue with a lot of activities without going out of our house. We could remotely control many of the activities. Of course, everything cannot be done sitting at home, but there are a lot of things which can be done. So the first principle of sustainability is to avoid what is not good. Then comes shift. If you are using a particular mode, you can shift to a better mode which would reduce what is not good. For example, if you are using a personalized vehicle, you shift to public transport. The CO2 emissions per person traveling in a public transport would be much less compared to what will happen if it's a personalized vehicle. And improve is, if you are using a IC vehicle, if you improve the efficiencies or reduce the emissions, then it would be better. Also, alternate technologies which are now available would also improve the overall carbon footprint of what we are doing. This is what is the trend basically in terms of we are looking for more fuel efficient, low emissions, more safer and lightweighting. Lightweighting is important because the resources what you use also have respective carbon footprint. So lower the weight of the overall components what we are using, that means the carbon footprint is lower. Right now, government is focusing on how to achieve energy security. Till 2000, we were all having only liquid fuels like gasoline and diesel. And in 1998, the natural gas was has been declared as a fuel for automobiles also. So in Supreme Court has mandated use of compressed natural gas for use on the taxis and buses in NCR. And subsequently, it was spread to other locations where natural gas pipeline was there, where all the taxis and buses run on CNG. At present, after almost 20 years of start of CNG as an alternate fuel, there is a penetration of about 19% in overall passenger cars. And one of the manufacturers has almost 30% of its vehicles in CNG mode. CNG has better carbon footprint compared to gasoline or diesel. And the emissions from the roadside emissions from CNG vehicles is also less compared to gasoline. And also, it is cheaper compared to gasoline and diesel. The liquid fuels what we use for automobiles, the gasoline and diesel, are refined from crude, and about 85% of our crude requirements are made through imports. So every year, considering the whatever new vehicles come into the market, the requirement of crude increases continuously, because the fleet of vehicles which are on road continuously increase. So the government in 2016 came out with the electrification of automobiles with two targets. One, to reduce the crude which is required for gasoline and diesel by using electricity for powering automobiles. As a result, as I mentioned, EVs have no tailpipe emission, so they are indirectly going to improve the air quality. And with good recycling of used battery, we will be able to recirculate the rare earth materials which are required for making the cells, so that our initial import of these materials for making cells and battery will come down subsequently. Also, CNG, right now, our power what we use for the electricity what we get is mostly from thermal stations which use coal as the source of energy. So there is lot of emissions from these thermal stations. However, government is very aggressively pursuing installation of solar panels for harvesting the solar energy for electricity generation. So right now the grid has a mix of almost 50% thermal power from thermal stations and remaining from non-fossil fuel sources like hydropower, nuclear power, and also solar installations. In addition, government also is now blending ethanol, which is a product from molasses and also other agricultural waste, which is being blended with gasoline, so that the amount of gasoline required for automobiles also goes down, and as a result the crude requirements also will go down. So right now we are with 20% blending of ethanol in the gasoline. Some of the problems we have with reference to adoption of electric vehicles is the battery, which is the source of energy, is very, very costly. As a result, at current price of these batteries, the total product cost goes very high, and in some sectors, the product becomes unviable. And also it requires imported rare earth materials for making the cells. And of course, charging infrastructure needs to be set up to facilitate charging when required. And one of the bigger concern for the user is the range. The range electric vehicle can move will depend upon the capacity of the battery, which actually plays a major role in overall cost of the electric vehicle. So as if we have to optimize on the battery side, then we need to have charging infrastructure well established and available at all major highways and in India at present, two-wheelers and three-wheelers electric vehicles have seen good penetration, and especially in three-wheelers is almost 34% now, and in two-wheelers is about 10 plus percentage, and we hope this will become nearer to 30% by 2030. Unfortunately, in case of passenger cars, as I mentioned, the electric passenger car, because of the battery size, will make the price positioning very, very difficult, and this is not viable for most customers. And right now, most of the parts which are required for electric vehicles are being imported, like cells, the motor, the controllers, etc. And government has come out with a PLI scheme to encourage people to invest for making cells and battery and also motors, etc. The automobiles have a lot of controllers which control various operations, the battery management system, the motor controller, and also the vehicle control system, etc. And they all need a lot of softwares to optimize the functioning of different systems and as a result the vehicle. So this is a good opportunity for Indian software engineers and also the electronic chip makers and for catering for these requirements of EV vehicles. As I mentioned, EVs, though there is no tailpipe emissions, because the power which is being used for electric vehicles is also coming from thermal stations. There is a lot of debate whether EVs are the best because they only shift the emissions from roadside to thermal stations or other places where the electricity is being generated. So, to understand the actual carbon footprint of various technologies what we have, like gasoline vehicles, diesel vehicles, CNG vehicles, or the ethanol blended vehicles using ethanol blended gasoline, and the electric vehicles, we need to do life cycle analysis, which means that you should start with actual materials being made up to the grave, which would mean that end of life of the vehicle, the recycling of various, dismantling and recycling of various aggregates, etc. Only then we would be able to compare which particular powertrain technology is good from point of view of carbon footprint. In case of CNG, government is also promoting biogas generation using the dairy waste and also agricultural waste, which they hope would serve the local requirements of villages through, biogas getting compressed can substitute CNG. I don't know how many of you know, basic biogas is also methane, which is same as natural gas. So, compressed biogas can directly replace CNG. So, this would also help reducing the import of natural gas in form of LNG from outside. The other promising alternate fuel is hydrogen. But hydrogen generation and also use as a fuel for IC vehicles and also fuel for fuel cell is still under development, and it all depends how efficient is hydrogen generation in terms of energy and how much it costs. That will decide how hydrogen can be adopted. Otherwise, hydrogen has no other uh, emissions. When you use hydrogen for IC vehicles, what you get out is water vapor. And similarly, in case of fuel cells, you get water vapor as the from the fuel cell system. But it is still under development stage, and it will take some time before we really know how hydrogen can economically, environmentally made and used for either fuel for IC vehicles or input for fuel cells. The major challenge what you have in EVs is the cost. And major part of the cost is battery. And batteries are being assembled in India now with imported cells. And also a lot of organizations are setting up facilities to make cells in India. So, but the challenge is China has already stabilized their manufacturing systems for making cells, and also they have big volume, and the cost what they have achieved is very, very low. So if we are going to make cells and battery assembly in India, the challenge is how we are going to meet the volumes and also how the cost parity will be achieved with what we are importing from China. That's a big challenge. And so just localizing what we are importing from China will not help, and we need to work on basic design of various aggregates to optimize the requirements of these systems to meet Indian requirement and Indian conditions. That is the only way we will be able to reduce the cost of these aggregates. So this is a big challenge for all the startups, because this can best be addressed by a startup, and if a existing manufacturer supports these startups, we would be able to meet the requirements of volume and the cost. When we started in 80s, there were hardly any electronics in automobiles. With introduction of various emission regulations and also safety systems, the number of computers on a vehicle have gone as high as about 15. And we are now talking about software-driven automobiles. So, in time to come is already, and in time to come, the content of electronics in an automobile is going to increase further, and is no longer automobile a mechanical engineer's creation, but mechanical, electric, electronics, software, all have to work together to come out with a smart automobile which would meet all the requirements of the customer user. So this is the challenge what we have in front of us, and how we are going to address this is the question. Prime Minister during Independence Day speech mentioned that he wants to create in India something Kavachi mentioned to safeguard our all our defense installations and other important installations. And he's clearly mentioned that he has faith in the younger generation to take up this challenge and come out with a product which would be adopted worldwide. So, I mean, all of you who are in engineering colleges or passing out of the colleges, is the right time, and this is the time when to be in India and work for India to address some of these challenges. I don't think you'll have more challenging assignments anywhere else in the world, and everything is happening in India, and India is very soon going to be third largest economy, and in automobiles is already third largest manufacturer of automobiles, and very soon we are working towards further increasing the automobile presence in India, because per capita automobile penetration is still very, very low compared to any developed country. So there is a lot of scope for growth of auto industry, and we have to make our automobiles environment friendly and also economically viable for the masses to adopt automobiles. Automobile can be either two-wheeler or a four-wheeler. So these are the challenges what we have to address. Thank you.
From mechanical department. Sir, as you told that we are going to reduce CNG gas to biogas.
Louder.
सर जैसा कि आपने बताया था कि हम लोग सीएनजी से बायोगैस की तरफ जा रहे हैं। सर जैसा कि हमने देखा था गर्मियों के सीज़न में देखते हैं कि जो सीएनजी होती है, सीएनजी गैस जो होती है, वो कभी कभी क्या होती है कि ज़्यादा गर्मी की वजह से वो फट जाती है, मतलब ब्लास्ट हो जाती है गाड़ियों के अंदर। जैसा सर मोस्टली मैंने देखा है, मतलब हमारे साइड में ऐसा हुआ था कि मतलब वो उसके सिलेंडर जो हैं वो फट जाते हैं गर्मियों की वजह से, मतलब ज़्यादा हीट की वजह से। तो सर जो बायोगैस है वो क्या वो बेटर ऑप्शन होगा सीएनजी को रिप्लेस करने के लिए?
No. In technical terms, biogas after removing the carbon dioxide which it has is methane, and natural gas is also methane. So they are interchangeable. And coming to your first question, the problems what you are mentioning about blast or bursting of gas pipeline, etc., we had in the initial days when we started conversion of existing vehicles in the market to run on natural gas. But now almost all the manufacturers who are making CNG vehicles are doing it in their own production lines, and you do not have any such cases reported of late.
Okay, thank you sir. Sir, next question is that सर अगर जो कार की बॉडी होती है, सर अगर उस पर हम सोलर पैनल लगा दें, सीट ऑफ सोलर पैनल लगा दें, और फिर उसके मतलब गाड़ी के अंदर हम बैटरी को स्टेबल कर दें, तो जो सोलर हीट होगी, सनलाइट होगी, वो सोलर पे अटैक करेगी, वो एनर्जी को एब्जॉर्ब करेंगी, और जो बैटरी होगी वो बैटरी एनर्जी को स्टोर करेगी। तो इससे क्या होगा, जो अभी जो आज की गाड़ी आ रही हैं चार्जेबल बैटरी जो आ रही हैं, सर उससे हम मतलब कॉस्ट को रिड्यूस कर सकते हैं, इलेक्ट्रिसिटी को भी वहाँ से हटा सकते हैं, मतलब लोग चार्जिंग पर नहीं लगाएंगे, सनलाइट से चार्ज हो जाएगी गाड़ी हमारी और बैटरी को स्टोर करके हम लाइट में उसको।
What you are saying is in principle okay, but practically what you are saying cannot happen, because for continuous charging of the battery which is used in electric vehicles, you need much more surface area to have the solar panels to generate enough power required for charging the batteries.
सर जो गाड़ी का सरफेस होता है, फ्रंट सरफेस होता है, सर उस पर हम पैनल लगा सकते हैं और बैकएंड में।
See, you cannot have solar panel everywhere, so normally it can be put only on the roof because that is the place where it gets exposed better. And there is a startup who is making a small car, and he has one variant of his small car with solar panel on the roof. So that saves about some 4 to 5% of energy which he gets from the solar panel. You cannot totally avoid charging by using the solar panel because you need much more surface.
Thank you, sir.
Yeah.
सर माय नेम इज पंकज मौर्य फ्रॉम ईसी डिपार्टमेंट. सर माय क्वेश्चन वाज दैट सर आपने बोला कि चाइना अपना लिथियम आयन ईवी बैटरी इंडस्ट्री सेटअप कर चुका है, तो क्या प्रॉब्लम है कि हम इंडिया में नहीं सेटअप कर पा रहे हैं? क्योंकि अपनी जितनी इंडिया में ईवी लिथियम आयन बैटरी है वो 70 to 80% चाइना से ही इम्पोर्ट की जाती है.
And government is very aggressive on promoting electrification of automobiles, and they are also promoting setting up of cell manufacturing in India, for which they are giving a lot of funds to the people who are coming forward to set up these facilities. But challenge, as I mentioned, is China has that lead over us. Okay, so they already have the volumes of cells. I mean, and also the price positioning of those cells is very low. So to challenge China in terms of volume and cost is the challenge, and we cannot just localize what we are importing from China. We need to think differently, innovate, and come out with the optimum solution for getting better price.
ओके सर, थैंक यू सर.
Good morning, sir. My name is Parv. I'm from GSS. I'm in mechanical engineering. My question is that we have seen in last years that EV is not doing any much of, it's not making as much as of impact in reducing the pollution. But when it comes to hydrogen, which is a new field of research for automobiles, where we have seen in Japan, especially Honda were making engines which are compatible with hydrogen fuel. So why aren't we focusing our field and R&Ds in the space of hydrogen?
As a result, every study is coming out with different results. Having said that, with the current mix of renewable and fossil fuel generation of electricity in India, with increase in the solar energy generation, which is happening now, the performance of EVs is bound to continuously improve, unlike other technologies what we have. That's one. Second, with reference to your point on hydrogen, it is still not very clear how we can make hydrogen both environmentally friendly and also economically viable. Still, research is going on, and the energy efficiency of making hydrogen is extremely important. Otherwise, we may end up spending more energy to get some energy in the form of hydrogen. And hydrogen as a fuel has a lot of advantages in terms of no pollutants coming out of combustion of hydrogen. It is water vapor which comes out. So that is there. But to achieve that, we need hydrogen. And also, in case of hydrogen, the storage and transportation of hydrogen is a big, big issue. So we need to develop systems to cater for those requirements. All those things will happen because still all the various aspects of hydrogen as a fuel are being developed. So it will take some time before you see hydrogen as a fuel. Definitely there is focus on hydrogen as a fuel, not only for automobiles but for other applications also.
Sir, my question is that I wouldn't say that they hate EV vehicles, but they prefer IC engines over anything. Sir, and as today market and industry as a whole is moving towards EV vehicles, so isn't this a global decline in the real automotive lovers?
No, I mean, what you're saying, I understand, but see, it's a question of how the vehicles get tuned. And already the people who are using electric vehicles are very, very thrilled about the drive what it offers, because we are using electric motor as a prime mover. and it has a constant torque curve, so the accelerations are extremely good compared to IC vehicle. In case of IC vehicles, especially gasoline, initial torque is very low, so it takes long time to accelerate. So, I mean, it's all question of how vehicles get tuned to cater for different requirements of user.
Yes, sir. Sir, but a big part of that affection is not just speed and acceleration, but a personal belonging by tuning and making their own vehicles, which is a very big culture in America.
No, why do you think that can't be done in case of EVs? The way the startups have come up making EVs, which were not there when IC vehicles were there, only means that it's much easier to handle a EV vehicle configuration compared to IC. Making an engine is very, very difficult and takes a lot of time and money, unlike electric powertrain.
Thank you, sir.